An aircraft structure is the load-carrying framework of an aircraft that provides the required strength, stiffness, and geometric shape for safe operation. It consists of all physical components that form the aircraft's body and enable it to withstand loads experienced during ground operations, flight, and landing. In simple terms, the aircraft structure acts as the skeleton of the aircraft, supporting all other systems and components. The aircraft structure is made up of major components such as the fuselage, wings, empennage, tail section, engine support structures, and landing gear attachments. Together, these components form the physical backbone of the aircraft and provide mounting points for propulsion systems, flight controls, fuel tanks, avionics, payload, and occupants. One of the primary functions of the aircraft structure is to support and transfer loads efficiently. These loads include aerodynamic forces generated during flight, inertial loads caused by maneuvers and turbulence, landing and ground loads, and internal loads due to cabin pressurization. The structure is designed with well-defined load paths to safely distribute these forces throughout the aircraft. The aircraft structure must maintain the aerodynamic shape of the aircraft under all operating conditions. Structural deformation can negatively affect lift, drag, stability, and control. Therefore, sufficient stiffness is built into the structure to ensure the aircraft retains its intended shape during flight and ground operations. Aircraft structures are designed to protect passengers, crew, cargo, and onboard systems while meeting strict safety regulations. They must resist fatigue, corrosion, and accidental damage over repeated flight cycles. Additionally, the structure must withstand environmental effects such as temperature variations and pressurization cycles, ensuring reliable and safe operation throughout the aircraft service life.